You are required to pipette 10 ml of a 1 molar NaOH solution into each of 2 square base containers shown. Container 1 will contain the standard, and container 2 will contain the sample. You should label each container as such with a marker. So the cap is labelled as standard for container 1 and as sample for container 2. So the first step of the practical involves weighing out the acetyl salicylic acid. For this you're going to put the weigh boat into the weighing balance. You'll then press the tare or 0 button on the bottom right hand side and then start to weigh out the acetyl salicylic acid. So 200 milligrams in total. Once you've weighed out the acetyl salicylic acid, you can add it now to the container labelled standard. Make sure this is completely added. In order to make the sample, you need to break up one of the tablets in tin foil and crush it completely until it's well crushed. You should periodically check that it's well crushed, and once it has been, you can now empty the contents into the container called sample. So carefully add it from the tin foil into the container. Once you've added both the standard and the sample to the containers, you can then vortex both of them for 10 minutes. This involves sending it to a constant speed and putting the container on top of it and allowing it to vortex until fully dissolved. Once you've allowed both the standard and the sample to settle for 40 minutes, you can then transfer it into a volumetric flask. So the standard gets transferred to the standard volumetric flask and the sample gets transferred to the sample volumetric flask. So make sure you use your funnel and pour the solution slowly into the volumetric flask. After you've done this, you can now add several washings to it by rinsing out with your wash bottle and pouring them into the funnel. You can do this several times over until you've come close to the mark of the volumetric flask. So once you come close to the top of the volumetric, you can then start to add water dropwise until you actually come close to the meniscus level. At this stage you want to add slowly dropwise until the bottom of the meniscus is just above the line as shown. This process is then also repeated for the sample volumetric flask. So in order to make up your standards, you're going to have to pour a small amount of the solution from the volumetric flask into a tube, from which you'll then take your aliquots. You are required to label a set of tubes for your standards, so label them according to your manual, with the 2 milligram per mil concentration of aspirin the highest and the 0 milligrams per mil solution your lowest or blank. Shown in your lab manual is a table which has the amounts required to making up the known standards. For example, for the first one you're going to have to pipette 1000 microliters of the stock solution A, or the standard solution, into your Epinurf tube. This will now have to be done for the amounts needed for the 1.5, 1.25, 1, 0.75, 0.5, 0.25 and 0 mg per ml solution until you have a full set of standards made. After you've made your samples and standard dilutions, you'll then need to label a second set of tubes for each one of your standards and a second set of tubes for your neat 1 and 2 and 1 and 5 dilutions of your sample. Following this, you're going to take 50 microliters from your standards and add them to 950 microliters of the iron 3 buffer solution. So 50 microliters using a P200 and 950 microliters using a P1000. This is then vortexed immediately. And then returned to the rack. This is carried out for each of your standards and for each of your samples, plus the neat and diluted versions of your samples. Once you've added the iron solution to all your samples and standards, you can now pipette 200 microliters in quadruplicate into your 96 well plate. It's a good idea to keep a map of your 96 well plate so that you know where you've added certain standards and certain samples. Once the plate is complete, it will then be read on the spectrophotometer at 540 nanometers. From this you will have to construct a standard curve from the standard concentrations you generated, and also determine the concentration of the unknown, which is the aspirin tablet, from your neat 1 and 2 and 1 and 5 dilutions that you made. You will then have to paste your readout into your copy and calculate the mean standard deviation and percentage variance for each standard and for each sample, and also to graph your standard curve and to calculate the concentration of your unknown from the graph.